Since the birth of agriculture, cows have been central to the human story. But recent years have seen growing awareness of the cattle's contribution to climate change. However, not everybody realizes that a large part of the problem is not about the number of animals, but also how we feed our livestock. This is how we experience dairy farming in Switzerland, cows roaming the meadows and eating roughage-based diets. Globally, the reality is different. In many parts of the world, cattle and other ruminants are fed in large feedlots, using a high proportion of concentrate. This intensified feeding method might make cows produce more milk, but it takes much bigger toll on the environment than pasture-fed animals. It uses much more of the scarce fertile land, contributing to deforestation, uncoupling of natural cycles, and causes more nitrogen and phosphorus pollution in the water than grass-feeding cattle. So, is there a way we can get farmers to do more grassland feeding without penalizing the animal's productivity? Yes, there is. This is red clover. It's incredibly common in places like Switzerland, and it's particularly valued for its ability to fix nitrogen from the air and thereby reducing the need for fertilizing the grasslands. We set out to develop a red clover with a high leaf starch content to increase the nutritional value of grassland-based diets by using state-of-the-art analysis to measure starch content on thousands of individual plants. Connecting the starch measurements from the lab with the unique DNA sequence from each individual plant, we were able to discover some of the candidate loci, or pieces of DNA, that explain the variation of the starch content that we see in the leaves. In principle, this process is the same as classical breeding that has been around for centuries, but with the understanding at the DNA level. We now have an idea which plants hold more energy using molecular breeding to produce a new generation of red clover and other forage crops with higher starch content in the leaves. This would mean that farmers wouldn't need to use so many high-energy grains. But there are still open questions. Starch accumulation depends on a lot of environmental influences, and we are only at the beginning of discovering how they affect starch turnover. We still need to shed light on these questions before it's possible for a high-starch red clover plant to be incorporated into red clover breeding and ultimately the field. Hopefully, one day, imported cereal grains could be replaced by a high-energy red clover plant, which is good news for the cows, for the farmer, for humans, and all other life on Earth.